Hey there, fourth graders. Today I wanted to go over the unit practice for the factors and multiples unit so that you could look at this before you complete your test because this information is going to be very similar to what you're going to see on your test. On my screen, you can already see that the answers are highlighted, but I do want to go over how to read through each question and also how to solve each question so that when you go to take your unit test, you have a better idea of what the questions are asking and what you can do to solve each question. So the first question says select all, and I just want to point out select all is really important. It does mean all, so you do have, anytime a question asks you to select all, you do have to test every single answer choice, okay? So it says select all the numbers that have an even number of factors. Now, don't think it says even factors, right? Or whatever, an even number of factors, which means if you guys remember back in the videos, I was talking about when we make our factor rainbows, we only have to list each number twice. Okay, so you can make factor rainbows, you can make arrays, you can just list the ways to multiply to get the number. It doesn't matter which way you do it. You just need to remember that you never need to list the same number twice when you're making your list of factors. So let's say for 8, I decide I'm just going to list the ways I can multiply to get 8. I know I can do 1 times 8. Okay, and I can do 2 times 4. And that's it, right? Sure, yes, I can do 8 times 1 and 4 times 2, but I don't need to list those numbers again because they're already listed. So if I say 1, 2, 4, and 8, those are my factors. Okay, and I have 1, 2, 3, 4 factors total. Is 4 an even number? Because that's what my question's asking me. Is 4 an even number? Yes, it is. So I'm going to check off 8. I'm going to do the same thing for 9. I can do 1 times 9. And I can do 3 times 3. All right. But when I list my factors, remember, I don't have to list 3 twice. I just list 1, 3, and 9. So this one only has 3 factors. Is 3 an even number? No. So that's not an answer choice. Okay, and you do the same thing for each answer choice. So for 15, you're going to go 1 times 15. You're going to say, no, not 2. I almost wrote 2. But 2 is not a factor. 15 is an odd number, right? 3 times 5. And those are the ways that I can multiply to get 15. Now, again, we don't want to get just tripped up by this word even because I don't want you to pick just the even answers. That's not going to be correct. You need to think even number of factors. Make sure you read really carefully what it says. If you need to reread a question twice, reread it twice. Take a second. Think about what it says before you start clicking answers, okay? So right here I have 1 times 1, 3, 5, and 15. Those are my factors, right? Sorry for my horrible screenwriting. I'm not a mouse writing expert, but that has 4 factors. 4 is an even number, which means 15 has an even number of factors. When I do 16, I can do 1 times 16. I can do 2 times 8. And I can do 4 times 4. Remember, I could do this all with factor rainbows. I could do this all by making arrays. All right. So when I list my factors for 16, I say, well, I have 1, 2. Remember, I only have to list 4 once. 4, 8, and 16. So that has 5 factors. 5 is not an even number, which means 16 does not have an even number of factors. And then now we have 25. Okay, so we say 1 times 25. Can't do 2, can't do 3, can't do 4. 5 times 5 is the only other way to do it. So I have 1, 5, and 25, which means that it only has 3 factors and it's not an even number of factors. Now, really quickly, I want you to stop and look at the question again. Okay, it is asking us to select all the numbers that have an even number of factors. And there would have been a really easy way to do this if you know this rule. I did mention it in one of my videos where I'm talking about factor rainbows, but I want you to see if you can notice it. What is similar about 9, 16, and 25? What do you guys see that's similar about 9, 16, and 25? I'm going to give you a little bit of a hint. They are all the product of doubles, right? I multiplied 3 times 3, 4 times 4, 5 times 5. So all of those are the result of doubles. And remember, when you double a number, 6 times 6, 7 times 7, you only have to list that number one time when you're making your list of factors. So the only numbers that are going to have odd numbers of factors are numbers that are the answer to doubles facts. All of the other factors, whether they're prime or composite, have even numbers of factors. The only ones with odd numbers of factors are the answers to doubles facts, okay? All right, let's look at the next question. Oops, forgot I have to. Okay. Which of the following numbers has an odd number of factors? Notice that this question is the same type of question you just answered. And I just said it. It's the only one that is the answer to a doubles fact. Okay, so think, which one of these is the answer to a doubles fact? Because doubles facts are the only ones with odd numbers of factors. 25 is, right? 5 times 5. So 25 has an odd number of factors because you only list that 5 once. All right. 13, 1 times 13. So 1 and 13 are the factors. We just did 15. If you did 26, 1 times 26, 2 times 13, still it's going to have an even number of factors. The only one with the odd number of factors is 25 because it's 1, 5, and 25. There's only 3 factors. Okay, let's look at our next question. This one says, Evan wants to make an array of 32 miniature cars. What are all the different ways that he can make his array? I want you guys to notice a keyword in this question. All. What are all the different ways that he can make his array? So remember, when we're making these arrays, we're not repeating facts, right? Well, we can repeat facts, I guess. Usually we don't, but we want to make sure that we are finding all of the ways, okay? So what I would do just as a test taking strategy is I'd go and look at the one that has the most answers. So this one has 1, 2, 3, 4, 5, 6, 7. And this one has 1, 2, 3, 4, 5, 6. Okay, so these two answer choices have, this one has 7 and this one has 6. Those would be the first two I'd look at because the likelihood that these have all of the ways is not pretty great. Okay, I want to think, what are all the ways that I can multiply to get 32? So let's look at the one that has the most answer choices. 1 times 32. Yep, that works. 2 times 16. Okay, well, I don't know my 16 times tables, but I can do it really quick, right? Just to double check. 2 times 6, that's 12. Regroup, carry my 1. 2 times 1 is 2, plus 1 is 3. So, yep, 2 times 16. 3 times 12. I can skip count by 12s because I know my 12s tables. 12, 24, 36. Ooh, that one didn't work, right? 36 and 32 aren't the same. So that one's not it. All right. So now I'm going to test my other one that had a lot of answer choices. I see some of the same numbers. 1 times 32. Yep. 2 times 16. Yep. 4 times 8. Well, if I remember my 8 times tables or my 4 times tables, yep, 4 times 8 is 32. That means 8 times 4 is also 32. 16 times 2 is also 32. And 32 times 1 is also 32. So this has to be my answer choice right here. Okay, these have less options. Do they have correct answers? Well, this one I already see has 3 times 12, and we just said that didn't work, so that one can't be it. In this one, 1 times 32, 2 times 16, 16 times 2, 32 times 1, all of those are different arrays we could make, but it's not all of the arrays because it's missing 4 times 8 and 8 times 4. So that's why that one's not the right answer. Okay. The last answer choice is the only one that has all of the arrays. Make sure we read really carefully. All right, which number is a multiple? Remember, multiples mean skip counting. Which number is a multiple of both 2 and 7? Well, what I'm going to do is I'm going to skip count by 2s, and I'm going to list them. And I'm going to skip count by 7s, and I'm going to list those. And I'm going to see if there's what number I say for both of them. And I see my answer choices. Okay, so it has to be one of these answer choices. I'm not going to have to go up past 35. All right. So if I'm skip counting by 2s, I go 2, 4, 6, 8, 10. Still none of those are yet. 12, 14. Ooh, I say 14. That's an answer choice. Let me try my 7s. 7, 14. Ooh, I say 14 for both of them. That means that 14 is the correct answer. Also, just notice every number you say when you skip count by 2s, every multiple of 2 is even. The only even answer is 14. So you didn't even really have to do this step if you remember that fact. All of my multiples of 2 are even. So my answer for a multiple of 2 has to be even. Okay, let's look at our next question. All right, this one has some words in it. So we want to make sure that we stop and think about the problem the way that we would for a regular word problem, all right, and break it down. Mary says that every number in the 70s is composite. All right, remember our composite numbers have more than 2 factors. So that you can do more than just 1 times the number itself. Tyler disagrees and says that every odd number in the 70s is prime. Every odd number in the 70s is prime. Okay, so we're looking at our numbers in the 70s. That means 70, 71, 72, 73, 74, right? 75, 76, 77, 78, 79, and 80. And I would guess that these are probably not numbers that you've made a lot of factor rainbows for, that you've done a lot of arrays for. Okay, so let's think carefully about what we know and what we've learned so that we can see if Mary and Tyler are correct or incorrect. And it says, which of the following statements is true? So only one of these is true. It says only Mary is correct. There are no prime numbers in the 70s. Okay, well, I'm not 100% sure about that just yet. Okay, so I'm going to just sit tight on choice A. Choice B says only Tyler is correct. Each of the prime numbers in the 70s are odd. So I'm going to look at my odd numbers first. I have 71, 73, 75, 77, and 79. What do I know about numbers divisible by 5? They all end in a 5 or a 0. All numbers divisible by 5 end in a 5 or a 0. So this number, I could do 5 times something to get 75 because it ends in a 5. Every number that ends in a 5 has 5 as a factor, every single one. So that means that Tyler is not correct. And so I'm going to look and see, are any of my other answer choices saying Tyler's correct? Because we just figured out Tyler's not correct. Only Tyler is incorrect. 75 is a composite number. Oh, man, I can't eliminate that because that's what I just figured out. Okay, so, and then we have both Mary and Tyler are incorrect. Prime numbers in the 70s are 71, 73, and 79. Okay, well, basically now we have to see if any of these numbers are prime. Okay, so let's think back through what we learned. Let's start with 71, because if 71 might be the easiest one to figure that out for. And if we can figure out if 71 is prime, it doesn't even matter if the other two are, because that means that there is a prime number in the 70s. And we know that 75 is a composite number, okay? So Mary is going to be wrong if we find any prime numbers. It doesn't matter how many we have. We don't need to find all the prime numbers. We just need to know that there is a prime number. So I'm going to pick 71 and I'm going to think, okay, 1 times 71. I know I can do that. Okay. So far it's looking prime. Is it even? No. So 2 is not a factor. When I add the digits together, do they equal 3, 6, or 9? Because if they do, 3 is a factor every time. 7 plus 1 equals 8. 3 is not a factor. Okay. For 4, there's no real trick. But I'm going to think, okay, I know 80 is 4 times 20, right? So let me just count backwards. 20, so 80, let's see here, 79, 78, 77, 76, 75, 74, 73, 72. I'm not going to say 71. So 4 is not a factor. Is 5 a factor? It does not end in 5 or 0. So 5 is not a factor. For 6 to be a factor, 2 and 3 both have to be factors. Neither of those are factors. So 6 is not a factor. Is 7 a factor? Again, no cool tricks for 7s. But let's think carefully. 7 times 10 is 70. Can 7 times 11 be 71? No. So 7 is not a factor. Is 8 a factor? Okay. Well, 8 times 10 is 80. If I subtract 8, I get 72. So 8's not a factor. Is 9 a factor? When I skip count by 9s, 9, 18, 27, 36, 45, 54, 63, 72. I don't say 71. 10 is not a factor, right? It has to end in a 0 for 10 to be a factor. My 11s, when you learn your 11s, it's pretty cool because they're all double digit number, like double repeated digits. So 11, 22, 33, 44, 55, 66, 77, right? So that would not be one of the numbers I say. Okay, and 12s, we, 12, 24, 36, 48, 60, 72. No, 72 has a lot of factors, it seems, as I'm sitting here trying to figure out what the factors of 71 are. But no, okay, and I've gone all the way up to my 12s. Is it possible to keep going? Maybe, but the reality is if you've figured out that none of the digits between 2 and 12 are factors, it's pretty likely that that's a prime number, unless you're talking with like a really, really big number. But with a 2-digit number, if 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are not factors, the likelihood is super duper great that that number is prime. So I feel very confident in saying that 71 is the prime number. And if 71 is a prime number, Mary is not correct and Mary is not correct. Because if only Tyler is incorrect, that means Mary is correct, right? So that means that they're both wrong. Also, another just little test taking tip. I had these 2 answer choices saying Mary is correct and Tyler is incorrect. Those 2 sentences are basically saying the same thing. If Mary is correct and only Tyler is incorrect, so only Mary's correct and only Tyler's incorrect, those would both be correct. And this is not a select all questions. That means there's only one answer choice. So only Mary can't be incorrect and only Tyler. Do you guys see what I'm saying? Like either Mary is right and Tyler is wrong. They're both right. They're both wrong, or Tyler is right and Mary is wrong. It can't be anything else. There's no other options. Okay. So there we have that one. All right, let's look at our next question. Okay, this one we have to drag the answers into the boxes. So these you really, really want to think about very carefully. You want to read this very carefully. Please read it more than one time. Okay, this is giving you a question and then you're answering the question and giving an explanation, but they're kind of giving you some sentence frames and you have to fill in the sentence frames. So you want to think really, really carefully. Okay, Joyce says that 4 is a factor of every whole number that has a 4 in the ones place. So every whole number that has a 4 in the ones place, 4, 14, 24, 34, right? We can keep going. Every number that has a 4 in the ones place, 4 is a factor. That's what Joyce says. Okay. I'm going to stop right there and I'm going to see if Joyce is right because it looks like I have to decide if who's right and who's wrong again. Okay. Is 4 a factor of 4? Yeah, 1 times 4, right? Is 4 a factor of 14? Does 4 times something equal 14? Nope. So Joyce is wrong. Okay. This is not right. I'm just going to write wrong. Wrong. Okay. All right. Joyce is incorrect. That's the first sentence, right? Joyce is incorrect. Okay. Nathan says 2 is a factor of every whole number that has a 4 in the ones place. So again, let's look at our 4 numbers that we listed. They all have a 4 in the ones place. So, yep, 2 times 2 equals 4. 2 times 7 equals 14. 2 times 12 equals 24. I don't know what 2 times what equals 34 without doing any division, but I do know 34 is an even number. And in fact, every number that ends in a 4 is an even number, and every even number has 2 as a factor. So Nathan is correct. Okay, so let's see here. Joyce is incorrect. Now it says, for example, 14 has a 4 in the ones place and does not have a factor of 4. That's what we figured it out, right? Nathan is correct. We just said Nathan is correct. 4 is even, and all numbers with an even number in the ones place has 2 as a factor. Okay, so it's really important after you've filled all these little blanks in, reread what you have filled in and see, does what I just said make sense? Does what I just said go along with what we just figured out? If it does, then good. If it doesn't, then fix it. Okay, don't just rush through to be done. You want to think carefully. Here's another one where we're filling it in. This question has 2 parts. Guess what, guys? If it has 2 parts, how many parts do you think you need to answer? 2. You have to answer both parts. I know, it's shocking. It's a shocking thing, but you do. You have to answer both parts. Don't leave part B blank. Okay? First answer part B, part A, then answer part B. What are the first 3 prime numbers greater than 12? So all of them have to be greater than 12, okay? I'm going to first look at my answer choices and see if there's any numbers that are less than 12, because sometimes they do that on tests, and you're like, hey, I can eliminate that because that's not greater than 12, okay? Oh, man, they didn't do that for us this time. So now I want to think, well, what are the first 3 prime numbers? It's really good to have memorized all of the prime numbers that are less than 20. I'm just going to kind of throw that out there. Okay, so 2 is prime, 3 is prime, 5 is prime, 7, 11, 13, 17, and 19 are the 8 prime numbers that are under 20. It's really good to know those numbers, okay? So I just said 13, 17, and 19. All of those are greater than 12, and all of those are prime. So I know that that's the answer. I can look at this list and I see right here, 15, that's a composite number. Right here, 21 is a composite number. And right here, these are all prime numbers, but they are not the first 3 prime numbers because 13 would be the first one. Okay, so I could actually eliminate this one and this one just simply because they forgot 13. All right, and then part B, can't skip part B. Jada says that if you take a prime number like 7 and double it, the new number is also prime. Do you agree or disagree? I'm going to test it out. Jada says if I take a prime number like 7 and I double it, so 7 plus 7, my new number is also prime. Is 14 prime? No, 14 is an even number. That means I can do 2 times 7. So I disagree. The new number is composite. If it's not prime, it's composite. It can't be both because it has factors other than 1 in itself, right? I could do 2 times 7. You see how I did that? I'm going to always test out what it says to see, is that true? Is that not true? Okay. All right, let's look. We have one more question on your practice, and it's another fill in the blank ones with the drop-down list. Okay, so 72 is a blank number. The choices are prime or composite. 72 is even, which makes 72 composite. It has blank factors and therefore blank factor pairs. Okay, here, I don't know. I have to figure out my factor pairs for 72. And remember when we were doing this earlier, we found out there were a lot, right? I could do 1 times 72. It's even, so I know 2 times something equals 72. All right, I don't know 2 times what off the top of my head, but I'm going to figure it out. Put 2 out here. 2 goes into 7 3 times. 3 times 2 is 6. I subtract. I get 1. Oops. Bring down my 12. 2 goes into 12 6 times. 6 times 2 is 12. And I subtract and I get 0. So 2 times 36. 3, well, I don't know. 7 plus 2 is 9. If you add the digits together and they equal 3, 6, or 9, 3 is a factor every time. 3 times what? I don't know. I'm going to do division. 72 divided by 3. 3 goes into 7 2 times. 2 times 3 is 6. I subtract. I get 1. I bring down my 1. Oops. And I have 2. 3 goes into 12. 4 times. 4 times 3 is 12. I subtract and I get 0. So 3 times 24. Okay. Does 4 go into 72? Well, if you remember when I did, I counted, I said, well, I know 4 times 20 is 80. And then I went down by 2 groups of 4. So 80, 79, 78, 77, 76, 75, 74, 73, 72. Yes, it does. So 4 times what? 4 times 18. What about 5? No, it doesn't end in a 5 or 0, so 5 is not a factor. What about 6? If 2 and 3 are factors, 6 is a factor. 6 times what? Well, let me see. My 12's times table. Let me think about those. 12, 24, 36, 48, 60, 72. Ah, yes, times 12. Okay. What about 7? No. What about 8? Yes, 8 times 9 is 72. And 9 is on the other side of the rainbow, so I'm done. So how many factors does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 factors, which means that it has how many factor pairs? Well, how many arches do I have in my rainbow? 1, 2, 3, 4, 5, 6. All right. All composite numbers are multiples of each of their factors. All composite numbers are multiples of each of their factors. Meaning when I say, when I skip count by 2s or 3s or 4s or 8s or 9s or 10 or 8s or 9s or 12s or 18s or 24s or 36s or 72s, I'm going to say that number. Think about if I skip count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. I say 2, right? 2 is a factor of 2, and I say 2 when I'm skip counting. What about, that's going to be the case of any of them. All of these factors, when I skip count by those factors, when I skip count by 8s, I'm going to say 72, right? Once I get to 8 times 9, I'm going to say 72. If I skip count by 12s, I'm going to say 72. I just did, right? 12, 24, 36, 48, 60, 72. Okay, the same is going to be true for all of that. So yes, all, and again, you can test it out, try it out, see what happens when you skip count by 4s or 8s or 6s or 12s or 18s. Do you say 72? If you do, then you can say all. Okay, and that right there is a review of your test. So, is it important that you have a good understanding of factors and multiples? Yes, it is a good understanding that you know how to find factors, you know how to find multiples, you understand what prime and composite numbers are. Is it important that you read each question very carefully and think about what each part of the question is saying to you? Yes, it's very important that you do that, because if you don't read it carefully, it's going to be really, really hard for you to find the correct answer. You need to stop and think and break it down one section at a time and answer one section at a time, and you guys will do great on this test. Make sure everything that has a part A has a part B, so answer both. All right, bye guys.